Hi, my name is Fredrik Sandblom from the NX marketing team. In this two-part tips and tricks session, we will be taking a look at the new sketch checking tool in NX, available from the NX 2024 December release. So, please make sure to stay tuned for the second part as well, as it contains very much important information on the usage of the tool. The sketch checking tool is a sketch relations integrity checking tool that can be toggled on or off while in the sketch task environment. It can also execute checks when exiting the sketch task environment to remind the user if there are obvious mismatch in the sketch relations. However, it is highly recommended to use the sketch checking tool toggled on from start and during the sketch creation process. It is always easier to define and correct sketch relations, dimensions, and intended behavior at the source, meaning continuously during the creation process. You can simply look at the sketch checking tool in NX as a spell checker while in a word processing software. So let's have a brief look to what the sketch checking tool looks like and some of the prerequisites. The option is available while in the sketch task environment. So to demonstrate, we simply choose to edit the last empty sketch in this example. The sketch checking tool is located on the ribbon bar, and when expanding the drop-down, we can see that there is a setting option for the tool. Evoking the setting options, we can see that we can control what checks to be performed, such as orthogonal relationships, concentrical relationships, etc. And note the very much longed for overlapping option. We can choose to run the check in regard to the display size or model size, where the display size takes a measured screen distance and zoom scale into consideration, and where model size measures in relation to modeling tolerance and independent from the zoom scale. Generally, the model size is recommended to use, but zoom level can sometimes be handy when using the tool. Distance, angular, tiny curves, and tangent at vertex threshold values can be modified to fit your specific situation. In addition, we can choose to execute the sketch check when exiting the sketch task environment if the tool is not toggled on and active. This is a good option as it can work as a reminder to the user if obvious sketch relations are missing, as some checks might pick up on relationships that are not to be considered issues. You have the option to ignore them. If a check is ignored, it will not be checked again. However, this behavior can be reset by using the reset all ignored checking results. So, to demonstrate, we will create a new sketch profile of an oil channel related to already existing sketch geometry. The profile will be a slot shape. We will do this twice using two scenarios to create the same final sketch profile in order to demonstrate the benefit of having the sketch checking tool toggled on and active during the sketch creation process, targeting a fully defined sketch. Note that we will intentionally create issues so that we can demonstrate the sketch checking tool properly. In the first scenario, we will create the profile curves first, and then we will toggle on the sketch checking tool to study the potential issues, and especially the amount of them at the given time. In the second scenario, we will start by having the sketch checking tool toggled on and active while creating the sketch profile and see how we can correct the issues at the source, as this is much easier when defining a fully defined and functional sketch. This approach is of importance, especially when creating large and complex sketch profiles. So let's start scenario 1, where we will create all the curves of the profile and with intentional issues first, and then toggle the sketch checking tool on to demonstrate the behavior and study the issues found by the tool. We first include the points from the existing sketch that defines the position of the inlet and exit of the oil channel. We continue by creating the circle around the inlet and then we copy the circle to the outlet position. Here we want the center curve represented, and so we create a line from the approximate center of the inlet to the outlet of the channel. We finalize by adding the outer lines to form a slot shape. We are now done with defining the in the profile participating curves, and so we now toggle on the sketch checking tool. We can now see all the relations issues found by the sketch checking tool highlighted on the screen as visual tags, as well as listed in the issues column of the sketch navigator. You can now from here interact with the issues via the visual tags in the graphical window, as well as via the sketch navigator, where the issues are listed in the issues column. You can see that there are a lot of issues to deal with at the same time when using the sketch checker tool post creation of the sketch profile curves. If this was a larger, more complex sketch, this might require quite a bit of time and effort to resolve. This concludes the first demo scenario of this two-part tips and tricks series. Please make sure to stay tuned and check out the part 2 with the best practice on how to use the tool properly. To summarize what we have seen in this tips and tricks session, part 1 of the sketch checking tool. You have seen that the sketch checking tool is available while in the sketch task environment. You have seen that the sketch checking settings can be modified to best fit the specific needs. You have seen that the sketch checker produces issues that are represented as visual tags in the graphical screen, as well as issues in the issues column of the sketch navigator. You have seen that the ignored or deactivated issues can be turned back on under the settings option. You have seen that using the sketch checking tool post creation of the sketch profile curves can produce a high number of issues that can be timely to sort. This concludes this first part of the tips and tricks session on the basics of the sketch checking tool. Again, please make sure to follow up with the second part in the series to get the best practice of the scenario presented to you. Now, with that final statement, I would like to humbly thank you for your time and attention.